Hi, good morning, good afternoon, good evening, everyone. Thank you for joining us for the last day of Azure Data Week. Thank you all for sticking with us all through the week. So our first session of the day is with Stan on using Azure DevOps for delivery of distributed cloud applications. So Stan, I'm going to let you get right into it.
Hello, everyone. Okay, so let's get started. My name is Stan, and let me say thank you for you all to joining us. And very sorry that we have only 1 hour to speak about this very big topic. I will try to complete all things in time and share with you some practice, but if not, I can assure you that I will release some video with the whole topics of this team, and you can see it on our portal. So before we started, let me introduce myself. I'm cloud and DevOps expert, and I'm almost 30 years in IT. Recently, for last 4 years, I completed about 15 cloud-based projects with implementing of DevOps. And I worked with very big teams such as Microsoft, Chevron, Lloyds, Wolters Kluwer, Mittler Toledo, and other. So I also have a title of Certified Azure DevOps Engineer Expert, and I'm mostly working in energy, commerce, and IoT, and finance and healthcare domains. So before we go to our agenda, I can say that this topic contains my experience how to implement a good CI/CD for the greenfield project based on the distributed clouds applications, and I will try to share my experience with you. So before we will have a look how to design a good CI/CD. Then we will have a look how to configure CI pipelines using Azure DevOps services, and then we can start looking at continuous delivery pipelines. So the first topic is design a good CI/CD. We'll have a look how to define quality gates in CI/CD, because this is the most important part. We need to map our tests to our CI/CD pipeline and consolidate them. We'll define branch strategy. We'll have a look how to define environments which we need and build CI/CD map. So the distributed cloud applications means 12-factor applications mostly. And you can use the link at the bottom to have a look what is the key concepts of 12-factor. I will not stop here. I will continue, and I can share some examples. So 12-factor applications are mostly microservices, event-driven architecture, or serverless. Most of them can be deployed on the private or public cloud, and it can raise some challenges for you. So distributed cloud applications means many small independent applications on the backend side. And main challenges are many repositories. So you need to maintain about 12 or 20 or even 100 repositories for your solution. You should maintain many pipelines, and it can raise a lot of effort for you. You need to have a look at the configuration management. And of course, the most important part is release management. So I will share my way how to resolve all these challenges. Let's have a look at this example from the Microsoft. As you can see, it is the serverless architecture. We have some APIs based on the Azure functions. We have some backend services. We have event-driven logic, and of course, we have a front end based on the web app. So all these applications should go live independently, and you should maintain their release pipelines in a more proper way without any issues and consolidate the effort. So let's start from the testing pyramid. Almost everyone from you knows what is this, but let me explain once again. At the lower basement, we have unit tests and code quality tests, which are quick, fully automated tests which we're using to check the code at the earliest stages of our CI/CD pipeline. Then we have regression and integration tests, which are mostly simple automated tests, which we are using to check the health of other solution before we can implement it on some environments. Then we have functional security and performance testing, which are mostly running by schedule for a long time and takes a lot of effort to maintain them. And on the spike of this pyramid, we have UI tests, which are mostly manual and less automated, but it requires a lot of effort for QA engineers to maintain them, and we need to explicit any other kinds of errors before we can achieve this kind of tests. So those axes mostly represent the complexity and fragility of the tests, independence of the amount of tests. So we have a lot of unit tests because they are very small, and each test represent very small part of the function. And UI tests are mostly performed by hands, and it takes very hard effort to, for example, to make it automated. So let's define and let's talk about quality gates. What quality gates we can have before the new feature can come to production? First of all, we have unit tests, which can provide code functionality feedback. And we have code quality tests, such as static code analysis and code smells and other kind of stuff, which provides code quality. Then we have regression and integration tests, which represents feature viability. So by using those tests, we can be sure that this feature is working, no errors so far, and we can go further. Then we have functional, performance, UI, and security testing. These are mostly based on the feature functionality. User acceptance tests represent the business logic compliance, and smoke tests, of course, represent the production exploitation feedback. But what is different, and how we can define which tests we need and which not? Let's have a look on another axis, which is cost of tech debt. Unit tests have the highest cost of the tech debt because if you didn't implement it at the start of your project, it takes a lot of effort to implement them on the latest stages. Code quality tests are also important because without code quality check, you can have a very good working solution, but the maintainability of this solution will be very low, and it will take a lot of time and money to make it more easier and maintainable. So nobody likes refactor the application. Regression and integration testing is very common thing, but it can be implemented on the latest stages because it's kind of automated tests which can be skipped, but it's nice to have them because when you raise a new functionality, you must create an integration testing. If you release a new feature, you must create an integration test for that just to check that it works fine with other services and nothing broken. Then we have functionality and performance and UI testing, which can be done on specific time of your project, and you don't need to pay much attention for them at the earliest stages when you're starting your greenfield project. But in the future, those are also important to achieve a good quality. Then we have user acceptance tests. User acceptance tests are mostly related to checking the business logic, if it works fine or not, and that also happens on the release candidate stage. So it can be done or it can be skipped for the MVP stage, for example. And then we have smoke tests, which are very common and very specific and almost every time doing by hands. So we don't need to implement them at the start, but the cost of the tech debt is very low because you can do that and you may don't do that. It depends on your choice. So let's have a look how we can define a branch strategy in this case. We can see here dependency of the code consistency from the time. And before we can get from the new feature development start to release, we must go through this way. So at the first stage, we need to check the code integration before we can merge our new feature to other code base. We must check that this code will not break anything in our existing code base. Then we must test our feature so we can be sure that feature works fine and everything is good and it's compliant with all our functional and non-functional requirements. And then we can go to release. But how can we map this chart to a branch strategy? If we will talk about the Git flow, which is very common branch strategy for the microservices architecture, we can say that we are releasing from the master branch. Because we don't use a release branch, because we don't need to have a code freeze and take a snapshot of the code base. We must have the latest consistent code on our master branch, and we will release our application from there. And my recommendation to start our development from the feature branch. So let's have a look how we can get from the feature to the master. On the Git flow, we can have code integration phase on the feature branch. So the next stage after the code integration checked, we can merge our feature branch to the dev branch, which will be most inconsistent because many teams can develop their own features and merge to dev branch very frequently. So we can run only quick tests, which not take a big effort for QA team to develop them. Then we can use the second intermediate branch, which is staging branch, and the mostly running there long running testing, because staging branch is more consistent and I would say changes live there in much bigger amount of time in comparison with their branch. And after everything is tested, we can merge our changes to the master. Let's have a look how our testing pyramids and quality gates are mapping to this. At the feature branch, we're mostly running code quality tests, unit tests, static code analysis, and availability tests. On the dev branch, we're mostly running regression and integration testing, which are very quick, and we can run them every commit to dev branch. On the staging, we are running the functional, UI, security, and performance tests because we have more stable code base and we can run those tests for a long time. For example, 1 night or 2 nights. And on the master branch, we're mostly making acceptance testing and smoke testing after release. Let's have a look at the advantages of the Git flow. Using the Git flow for our cloud application, we mostly have continuous deployment process. development process. Sorry. We don't need to make code freeze because we have two intermediate branches, and that allow us to test new features on the lower branches and make tests of the functionality and develop new features in other branches. And we also have always consistent code in the master, because two intermediate branches allows us to filter almost everything from our code before it can achieve the release stage. The disadvantages is more, I would say, long lead time, because it takes a lot of time to merge from the feature to dev. However, it can be done in automated way, and I can show you how it can be done. Then it needs to be approved by QA engineers and merged to the staging, and then it should be tested again and merged to the master. So it takes higher maintenance effort. And it mostly fits for complex microservices solution with large development team, because we need to be sure that every change is tested, and we don't want to interrupt other services by implementing this new feature in a fast way. The second branch strategy, which fits to this distributed cloud application approach, is trunk-based. In trunk-based, we have release from the release branch, and as always, we are starting from the short-living feature branches here. But we also have code integration phase on the feature, but we have only one intermediate branch, and we have very frequent commits there. So trunk branch is very inconsistent branch, and it's using for collecting all features from whole development teams, and it's mostly used for testing and integration between multiple features and services. So most of tests are performed there, and only when tests all tests are passed and successful, we made a code freeze and merge our changes to release branch or create a new release branch, and from there we can run a release. As in previous picture, we have code quality tests and unit tests and all this kind of static code analysis and code quality checks here on the feature branches. And we have the whole amount of tests on the trunk branch. And as always, we have acceptance testing and smoke testing from the release. Advantages is very short lead time, so it takes very less time to achieve a release stage, and it takes lower maintenance effort because you don't need to store all these pipelines for each of branches. And the disadvantages here requires the high level of test automation and high developers discipline. What does it mean? In trunk-based development, the whole pyramid should be done in a trunk branch. And if you commit a new code there, it should be tested from the basement till the spike, almost everything. And almost everything should be done automatically because the commits are very frequent and you need to do it as soon as possible. And also it requires high developers discipline because you should commit every short time. You shouldn't make long-living feature branches, and you should make it in a more proper way, make some documentation for your code and so on. So yeah, that's more difficult from my point of view.
All that, so you said that.
Sorry?
Hold on, don't say anything real quick.
So it also fits for small serverless solutions and small development teams because, for example, if we have a small application which takes about 50 rows of code and we need to maintain it, it does require to split it across 4 branches. So you can make short changes in a feature branch and merge them to trunk and use the high-level automation of the testing and quality assurance to merge it and create a new release. Okay, so let's have a look at the types of the environments which we have. Nowadays, we have those types of the environments on our project. So it's built environment, which is mostly using for low-level testing, like a static code analysis and running code quality checks, even making a short-term deployment and making availability tests before on the pre-merge stage, I would say. The next is development environment, which is mostly using for developers and running some short tests there. Integration environment, which is split from the development because sometimes it requires an additional environment to make a deployment there and make the integration testing. Also, we have functional environment, which is mostly using for running functional testing, which is also split out from other environments because it can be done in a parallel way with integration, for example. We also can have security, UI, and performance environments. I will talk about them a bit later. We also can have UAT and production, and the latest is staging environments. So all these types of environments are using for running specific types of tests for a specific version of your application package. But sometimes customers and management doesn't have such big budget for keeping those environments in place. So sometimes the scope of environments are very limited, and it contains from the build, development, QA, UAT, and production environments. So let's have a look how can we map our branch strategy and our testing quality gates to those environments. So the first of all, we're starting from the build environment, which is also running quality tests, unit tests, static code analysis, and availability tests. Then you can trigger integration tests and regression on those two environments. Then we have functional security and performance testing in parallel way. And then we can have UI testing, user acceptance testing, and deploying on a production and staging environment. Staging in this case will be using will be used like a clone of the production and is mostly related to the development purposes. In other case, we can use this flow where we can almost everything done on the QA environment, and we can run regression and integration tests on the dev environment. And of course, we can run security and performance testing on the UAT part. So let's have a look how can we map our environments on this chart. First of all, when we start developing of the new feature, we are running a new build after commit and deploy it on the build environment. So we're running there all this amount of tests, and if everything is okay, we are merging our code to the dev branch. There we can start a new build, which will make a deployment on the integration and dev environments, and we will run another part of test there. When we can merge, if everything is fine and all automated tests are passed successfully, we are cloning our code to a staging branch, which is more consistent, and we're writing a new build and deploy it to this amount of environments for functional security and performance testing, and only then we can do the UI testing, just to prevent unnecessary effort for QA engineers. And then we merging our code to the master. We are running and building production version of the build, deploying it on the UET environment, and then we can deploy it on the production and staging. So by using this CI/CD map, you can easily design your CI/CD and combine your branch strategy with the release flow and the quality gates here. In other case, for the trunk-based development, we can use lower amount of environments and we can map our testing like this. So let's talk about configuring CI pipelines. We'll talk about variable groups, using task groups, and using gated builds. Before you will start design your CI pipeline, you should keep in mind that all the configuration which you have should be stored somewhere in variables, but it's a best practice to split your variables according to their scope across the multiple variable groups. For example, we have variable group with a global scope, which contains static values which are valid for almost for everything for entire solution. For example, we can name it as vars global. And as an example, it can contain a pattern of the Azure resource group. The second type of variable group can be attached to a specific environment. And we can use the following pattern with the placeholders to name it, for example, prj vars.dev. And it will contain very specific values for specific environments. For example, environment name, location, DB server name. And the third type of the scope should be service specific and environment specific. So it combines service and environment values and valid for a specific service on a specific environment. And it can contain such kind of values, for example, service name, database name, and connection string for a specific service. You can also map secrets from the Azure Key Vault. It's very good practice to attach them through the variable groups and split out across the scopes also. So you can use the same types of the environment variable groups and the same patterns. So it also can contain some common security settings, some environment specific security credentials, and service specific. So let's talk about task groups. The typical build pipeline looks like this. First of all, we have a Git repository. When we have code check-in, the CI trigger starts a build. And almost every time we are building our dependencies first. When we can build our solution, which will use those dependencies, such as common DLLs and all this kind of stuff. When we're running unit tests and static code analysis, then we can do a code quality check and, for example, deploy in the built environment and run some availability tests there. And only when everything is successfully passed, we can publish our artifacts. And of course, we are using Azure DevOps pipeline for that. But what we're going to do if we, for example, have 3 microservices with 3 similar pipelines? Do we need to maintain them separately? Of course, no. We can split the most common tasks to a task group. And using this task group to attach for entire pipelines, so each microservice can trigger their own pipelines, but use the same task group and produce their own artifacts. And of course, you can map your variable groups from any scope to your pipelines here. I recommend to use a common dependencies pipeline in a separate way, so it can build the common artifacts which we'll be using for those task groups for microservices pipelines. So about gated builds, when we were talking about the feature branch and code integration checks, I mostly mean that we should use gated builds for that. For each microservice, we can set up a branch policy, which can map to, for example, feature, bug fix, or hotfix directory branches. So it can be triggered by a pull request and use the same gated build task group. By using that gated builds, we can exploit from the main artifacts build all this amount of tests, such as code quality check, unit testing, and static code analysis, because we are doing it at once on the primary stage. But then we can use it for pull request autocomplete, and after our code merged to the dev or trunk branch, we can start the CI build, which contains very less amount of steps, just only building of the binaries and small tests there because almost everything has been tested at this stage. And then it can produce the artifacts, which can be deployed on some environment. So let's talk about CD pipelines. When we're talking about distributed cloud applications and all this amount of branches and builds, we must keep in mind that every branch will produce their own types of artifacts. So how can we handle and maintain this logic? For example, we'll have one common pipeline with 3 types of artifacts. The first artifact will be produced from the dev branch, second from the staging, and the last one from the master or release. In Azure DevOps, we are mapping continuous delivery trigger there. So each new artifact can trigger this release pipeline. For example, if we have a dev environment attached to the first stage, we can configure a filter for a specific branch. So only dev artifact can trigger release for this specific dev environment. And after the dev environment, we can, for example, deploy our package to the integration tests by schedule. In relation to the staging branch, we also can filter them and attach it to the functional tests. And after functional tests, we can perform security tests and performance tests on these types of artifacts. And after everything is completed, we can trigger a manual approve from our QA engineers and deploy it on UI testing environments, so some UI tests can be performed there. And for example, if you have UAT in production environment, we also can filter artifacts by master branch and deploy only those types of artifacts to UAT environment and to production environment. But everything will be maintained by a single common pipeline. So by using this approach, you can maintain your CI/CD pipeline in a more better way and reduce the effort because you already set up this kind of logic here. You don't need to have a separate release pipelines for a specific branch. Okay, let's talk about stages. Stages inside the pipeline is mostly related to a specific environment, and each stage contains some pre-deployment conditions and post-deployment conditions which are responsible for the release logic. So as you can see here, pre-deployment conditions has always approvers and gates. So about approvers, it's mostly related to getting approval from a specific role or group of people. For example, QA engineers. It is also important to have approvers before we deploy in some packages to UAT or production environment. And it also contains gates, which are very short automated triggers, which allows us to check that the release can be proceed without any issues. For example, we can check that the tasks are closed, or we can check health monitoring or do some API requests there and be sure that nothing will broken from our side. Inside the deployment process, we have jobs, and inside these jobs, we have snippets, which are automated tasks. And of course, using serverless logic, agentless logic, we can use manual intervention task, which is more convenient when, for example, we need to deploy something and check is everything is okay, and we can use this manual intervention task to proceed the deployment on other stages. Post-deployment conditions contains the same gates as approvers, and it's mostly used to mark this stage is fully completed. And so next approvers can check that everything has been tested and everything is okay, for example, and the stage has passed successfully. Okay, let's talk about the best practices from my side. You should design a draft before the implementing. Before you can proceed with implementation something, you must draw your own release map, define your branch strategy there, build a common architecture of your processes, and only then you can implement it so everyone can understand what you do and what should be done as a result of this project. You should split your code through the application pipelines and configuration management through the infrastructure pipelines. So you don't need to do some configuration transformation inside your application release pipeline, because you can also map your configuration to your infrastructure and maintain all your settings through the infrastructure as a code pipelines, which is the next topic of this day. So you also need to consolidate variables and tasks. As I shown you, variables should be split across their scopes and can be attached in a more easier way to any pipelines, and use task groups or some patterns and templates to consolidate your effort to maintain your pipelines. Measure your results, because it's very important to have a look how your changes affect your existing pipelines. So if it increases the time of the process, so you must think that you can do it better way. And keep your solution as simple as possible means that it should be maintainable and adjustable. Please don't use very big amount of scripts, and if it's possible to use, for example, snippets, which are by default in the Azure DevOps, please use those snippets because it's more easier to maintain them instead of debugging some kind of PowerShell framework. And of course, evaluate your implemented solutions, because the most important part when you have a look in the past and see what kind of solutions you implemented, what were mistakes, how it can be improved, and that can teach you what you should prevent in the next steps in your career. Okay, I think I've completed almost from my side, so we have a couple of minutes to have Q&A session,
Okay.
and I can answer questions in this case.
Sure. So the first question is, does this methodology work for Power BI work? Seems more just like .NET code for web pages, but would love to have something automated for governed release of Power BI.
It mostly works for a complex logic. For example, if we have a data-driven project and we want to process this data through some pipeline, for example, for IoT, and we're collecting some data from the IoT hub, but we need to, before we can push it to the Power BI, we need to transform this data and, for example, filter data from unnecessary fields. We must have some applications there. And almost every time it contains very big amount of applications in the middle between the source and the destination, which is like Power BI. And to maintain this solution, this approach is the best way, because you don't need to have very big amount of pipelines and complex logic to do that. You can only plan, map your solution through the branch flow strategy, release strategy, and software development lifecycle. And after that, you can easily implement it in any kind of solution which you have.
Okay. So somewhat similar question, would this CI/CD framework apply to ADF?
Data Factory can be also done by this, so you can maintain Data Factory because you can store your code somewhere in, for example, in repository or in a separate artifact storage. And of course, you need to test your code before you can implement it somewhere in production site. So this logic also fits to any, I would say, any scripts or jobs or serverless work which you have. So it also fits for Data Factory pipelines.
What is the best tool/software that is recommended for infrastructure as a code for Azure components? Example, there are many out in the market like Ansible, Terraform, Chef, etc. Thinking in terms of a hybrid model.
If you're talking about the hybrid model, I would recommend to use Terraform and Ansible, but just to run out from the vendor lock. And of course, you can use Azure DevOps pipelines for implementing those infrastructure as a code changes. The common approach will be the same. You must build your branch strategy and store your code from the features till the master release, and test your code on any other environments. So yeah, I would like to say that I was using Ansible playbooks and Ansible frameworks for a big project on a hybrid cloud, which is combination of the Azure public cloud and Azure stack. And I can say that this approach also fits to those requirements.
Okay.
Because it was done very fast. Almost for 1 month, we implemented the entire solution and CI/CD pipeline for that.
Okay. Can the tasks include PowerShell effectively passing parameters?
I would say yes. If you want to use some custom PowerShell scripts inside your pipelines, you can use them. But I would like to prevent you from using a complex PowerShell frameworks to maintain the whole amount of your tasks, because it's very hard to debug and to refactor your code. For example, if you need to provide a knowledge sharing for that, it will take very big amount of time. So if it's possible, you can use these PowerShell scripts inside the pipeline, but just don't make it as a framework for the entire solution.
Okay, great. Well, I think those were all the questions. We had a lot of votes on several of those questions. I think people had similar questions. So Stan, thank you so much for kicking off the day for us with a great session. Thank you everybody for attending. I hope you guys can go get a snack or some coffee before the next one, and we'll see you on the next session. Thanks again, Stan.
Thank you very much.
Have a good one.
Day.